Hi. So today's video is going to be on the introduction of graphing quadratics, graphing quadratic functions, graphing quadratic equations, graphing parabolas. They're synonyms. So quadratics, parabolas, we're going to go ahead and graph one example, y equal 2x squared. We're going to be working off vertex form of quadratics first, and we're just focused on one aspect of the vertex form of a quadratic, and it's quite a bit of detail. There's a lot of writing as far as vocab. You're going to hear me repeat the vocab words over and over again, and we're going to just build on it. And then I'll assign you 4 quadratics for you to solve. And then, of course, I will go over them, one other one, and I will write it out very detailed, because you have to be able, when you take an assessment off of this, you have to be able to tell me all the aspects, all the characteristics of the quadratic or of the parabola. So we're just doing baby steps here, okay? All right, here we go. Okay, day 1, graphing quadratics or graphing parabolas. All right, so here we go. We are only focused on the a value. So how it says today's focus is that a value. So vertex form, this is vertex form, which I guess I should have written that. This is vertex form. Okay, this is vertex form of a quadratic. It is y equal letter A, and then quantity in the parentheses, x minus h, quantity squared plus k. We are only focused on the a, and that's the one example I'm going to solve. You'll get 4 quadratics to solve and repeat what I have done. And I know this example is going to be very wordy and quite long. So you might have a question as to like, how am I supposed to duplicate this and what are the essentials? I will let you know. Okay, so when I upload the second video, I will have it written out as far as what you need to tell me. And then I realize this is all very, very new to you. So then when I then solve one of those homework problems on another video, I will use that homework problem and I will label it and just make it completely detailed as far as what will help you moving forward. Okay, just get you to understand it and master it. All right, this is huge for integrated math 3, so you have to know it. All right, here we go. Our example is y is equal to 2x squared. This is our parabola. So notice the rest of this vertex form, we're not using it. We will eventually build upon it, but right now we are just focused on that a value, okay? All right. What is the value of a? Okay, so a is that front integer, or it could be a fraction or a decimal, positive, negative, but here it is 2, okay? So let me switch hands here. So what is the value of a? Our a value is this right here. And so our a value is 2. Okay, is the value of a positive or negative? You look here, you do not see that negative symbol. You don't see the positive symbol, but it is assumed to be positive, right? And so it is actually positive, correct? So this is positive, right? This is a positive 2. Ooh, can't see, correct? Okay, it's a positive, right? The a value is positive 2. Okay, so now here are your choices. I asked you if the a value was positive or negative. Doesn't matter. Yes, it matters very much. Okay, if the a value is positive, then that means the a value would be some positive integer, fraction, decimal, right? If a is negative, you would have that dash, which would represent the negative value, right? The negative symbol. Okay, if the a value is positive, then the concavity is upward or it is positive. What does that mean? It is concave up, or the concavity is positive, or the concavity is upward. Either way, the parabola or the quadratic is going to be going off to infinity upward. Okay, so its lowest, well, we're going to go over this, but this is essentially what it would look like. Depending how skinny or wide, that also depends on the a value, but we'll get to that. Okay, if the a value is negative, then the a value will be negative and then some number. Okay, so you're going to see that symbol. Concavity is downward or negative. So the concavity is downward, the concavity is negative, or it is concave down, which means it's going to be in this direction, kind of like a rainbow or a sad face, and this is like a happy face or a U, right? Okay, so that's the importance of the a value. The a value dictates whether it is concave up. The a value dictates or whether it is concave down. So the a value is what determines whether it is up or down, and that is determined by whether the value of a is either positive or negative. That's it. Okay, so is the value positive or negative? It is positive. So what do we know then? We are on concave up. So I know that since this a value is positive, that this is going to be a concave up parabola. So our parabola should look like this. So if you're ever, when you are solving the XY table and you start to plot the points and it is going in the opposite direction, you need to go back and see, did you make a negative error? Did you pick inappropriate points? Did you substitute incorrectly, right? This is your visual check. It does matter. Okay. All right. So here we go. So now moving forward. So all we did was use our eyes to find the a value, and then of course analyze, is it positive or negative, and then by that, is it concave up or concave down, and it's concave up. Okay, we need to fill in our XY table. Now, you don't just get to choose. Now, for the beginning, because we are focused on just the a value, if you notice the vertex form, we do not have all of this here, but it is there. Right? Remember, if you don't see it, it's a 0, correct? So what you are really seeing, and I'm going to write it over here, is this is in vertex form. However, if h is 0 and k is 0, then when you clean it up, you essentially get this. So if we want it to be very detailed, we will get y is equal to positive 2, right? X minus 0 squared plus 0. So these two are identical. Okay, so here we go. So for today, since we're just focused on the a, all of our examples, these two are 0, 0. The h and the k value are 0, so our vertex is going to be 0. Okay, we're going to fill this out, but first of all, what is the vertex? What is the vertex? It's a point. It's a very important point, okay, in a parabola. It's the change from either the parabola goes from increase to decrease or decrease to increase. All right, what does that mean? Well, if you have a parabola, right, you're decreasing, you hit your vertex, and then you start increasing. If you're concave down, you are increasing, you hit your vertex, and now you start decreasing. So that is what increase to decrease or decrease to increase means. Or generality, it's the turning point of the parabola. So it is that change from decrease, increase, increase, decrease. So it is that change. Okay, so if it is concave up, which is this is the one that we're dealing with today, since if it is concave up, your vertex point is going to be your minimum point or your lowest point on the parabola. If it was concave down, which we'll get to one of those, it is here. And so your vertex becomes your maximum point or your highest point. As we solve these, and we're going to solve a lot of them from day to day. I'm not just going to throw like 12 of them at you today. We're going to do just 4 of them. And then, of course, I'll do an example of a negative, just, you know, so you guys don't get thrown off. All right. Axes of symmetry, or A period 0, not 0, O period S. AOS, or axes of symmetry, is a vertical line. We're going to make it dashed, though. We're going to make it a dashed line because we don't want it to take the center point of the parabola. So we're going to make sure it's dashed. That divides the parabola into two congruent halves. Okay, it always intersects with the vertex, and equidistant. You're going to hear me say equidistant because we're going to have symmetry within our parabola. We're going to have symmetry within our xy table. Okay, and equidistant means at equal distances. So we'll get to that, okay? All right, so here we go. We're going to pick our xy table. And for now, since we are doing the basic